These are the notes for 2-6 using zero property or zero product property to find solutions. Given a and b are real numbers and a times b equals 0, and a equals 0 and b equals 0. For example, if we have x minus 10 times 3x minus 6 equals 0, we set x minus 3 equals 0, 3x minus 6 equals 0, and then solve for x. Using that method, let's move forward to solving some examples. So in example 1, both factors will be set equal to 0. So that we may solve for x. Let x equal -4. The other one, add 6 to both sides, and x equals +6. In example 2, both factors will be set equal to 0. 2x minus 4 equals 0. 6x plus 3 equals 0. By doing so, we'll be able to solve for x. Add 4 to both sides of the equation. All by dividing by 2. As per isolating x equal 2. And then subtract 3 on both sides of the equation. Then divide both sides by 6. Reduce -3/6 to -1/2. In example 1 and 2, the factors are given to us. However, in example 3, we need to obtain them first. Factors of 8, or factor pairs of 8 is 1 and 8, 2 and 4. The one we'll use is 2, 4 because the difference is 2. Or use x plus 4, x minus 2. And set each factor equal to 0. Solve for x. Add 2 to both sides of the equation, x is 2. Therefore, making sense, x squared means quadratic. Quadratic could mean 2 solutions, and we did find 2. Factors of factor pairs of 5 would be 1 and 5 only. Which one takes on the negative is 5, because 1 minus 5 is -4. Therefore, our factors will be x plus 1, x minus 5. Therefore, x plus 1 equals 0, minus 5 equals 0. X is -1. Add 5 to both sides of the equation, and x is 5. Next, we come back to factor perfect square trinomials, except now we're going to solve. Being that we could obtain the square root of the first and the last term, we would obtain the factor 3x plus 5. Being that it's a perfect square trinomial, both factors are the same, being 3x plus 5. Notice we have the same binomial, factors. Therefore, all we need to do is set one of the factors equal to 0, being the other answer will be the same. Then subtract the 5 on both sides of the equation. Then divide by 3. For x equals -1 and 2/3. Except this multiplicity is 2, which we will learn about in polynomials. In example 6, we have a perfect square trinomial. Why? Because we can take the square root of the first and the last term. Doubling that would give us the middle term. 5x. Now we have a minus on the middle term, so we're going to have a negative in the factor. Square root of 16 is 4. Factors being the same, we would set one of them equal to 0. Solve for x. Add 4 to both sides of the equation, followed by dividing by 5. Therefore, x equals 4/5. Next, we'll solve by factoring. However, now our a is not 1. And choosing bottoms up in example 7, 2 times 3 is 6. X squared minus 5x plus 6 equals 0. Factors that work is 1 and 5, 2 and 3 for factor pairs. The one we will use, though, is 2 and 3 because it adds to 5 and it multiplies to 6. Since we need -5, it's -2 and -3. We don't want to solve for x yet because a was originally 2. Bring it back as a denominator for the bottom. Bring it up after simplifying. In this case would be x minus 1. 3/2 does not simplify, so we bring the 2 up. Then set each factor equal to 0. Solve for x. Add 1 to both sides of the equation, x is 1. Add 3 to both sides of the equation. And divide by 2. Therefore, answers for x is 1 and 3/2, or 1.5, or 1.5. For example 8, we're going to multiply 9 times -8. X squared plus 21x minus 72 equals 0. Factor. This one was a little bit tricky, but the correct factor pair is 24 and -3. Being that a was 9, we want to bring it back as a denominator. Without it, originally we're seeing that a is 1, which is not. Then simplify, we obtain this. Divide by 3 is 8/3. And divide by 3 is 1/3. Complete the process by bringing the bottoms up. 3x plus 8. 3x minus 1. Set each factor equal to 0. Then subtract 8. Divide by 3. So x is negative 2 and 2/3. Another one would be adding 1 to both sides of the equation and dividing by 3. Keeping our second result, x equals 1/3. Okay, example 9. Complete the same process, except now we'll start with factoring out a GCF. When solving, after factoring out the GCF, we can then divide by that greatest common factor. Take out a 3 and we're left with x squared minus 2x minus 3 equals 0. Divide both sides by 3. Now if there was an x with the 3, we would need to set that factor equal to 0 because it becomes a factor, not just a coefficient. Leaving us with x squared minus 2x minus 3 equals 0. Factors of 3 that create a sum of negative 2 would be positive 1 and negative 3. Set each factor equal to 0. Then solve for x. Subtracting 1, x is negative 1. So adding 3, x is 3. In example 10, we have both a common factor of 5 and x. Therefore, factoring out of 5x, what remains is x squared minus 4 from dividing each term by 5x equals 0. Set each factor equal to 0. Then solve for x. Here we divide by 5. For x is 0. Here we have choices. We can factor it or we can solve by square root property since we have a squared. Therefore, x squared equals 4. Using the square root property, take the square root of both sides. Therefore, we get x equals plus minus 2. Notice that 3 was the original exponent. Therefore, it should make sense to you that degree 3 means 3 zeros, 3 x-intercepts, 3 solutions for x. This concludes the notes for solving quadratics using factoring. Once again, a is not 1, trinomials that have a GCF, etc. Thank you.